day 317 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 41, first missing positive. The difficulty level is hard, but you already know not to worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Question says, given an unsorted integer array nums, return the smallest positive integer that is not present in nums. You must implement an algorithm that runs in big O of n time and uses big O of 1 auxiliary space. So, now that we've read the question, let's go ahead and take a look at these examples so that we can make sure we're doing this question correctly. Now, in example 1, we have the input nums equals an array of integers 1, 2, and 0. The output is 3 because the explanation says the numbers in the range 1 of 2 are all in the array, so we add 3. Because remember, we want to return the smallest positive integer, right? And so in this case, all the integers leading up to 2, 0, 1, or 0 and 1, 0 is not a positive integer, but that's where there's 1 and 2, they're already in the range or already in the array. So the next smallest positive number that we can add to this array is 3 because all of the other positive numbers less than 3 are already in the array. So let's go ahead and take a look at example 2 where they might try to throw some tricks in our way, right? With some negative numbers. So in example 2, we have the input nums equals an array of integers 3, 4, -1, and 1. This time the output is 2. Explanation says 1 is in the array, but 2 is missing. So, excuse me, y'all. So if you look, we have -1, then it goes to 1, then it goes to 3 and 4. So if you notice, you might say that 0 is missing and 1 is missing. 2 is missing. 0 is missing and 2 is missing. And you might think, oh, 0 is smaller than 2, so why don't we return 2? Why don't we return 0? We don't return 0 because we want the smallest positive integer, and 0 does not count as a positive integer. 0 is 0. So in this case, we return 2 because 2 is the smallest positive integer that is not already included in this array, right? We have the 1 right here, and we have the 3 and 4 right here, but we don't have a 2. So that's why 2 is the smallest positive integer that is missing out of this array. So let's go ahead and look at example 3, where it might seem a little tricky as well, but once you understand what's going on, it's not that tricky at all. So in the example 3, we have the input nums equals 7, 8, 9, 11, and 12. The output is 1. The smallest positive integer that is missing is 1. So remember, we want the smallest positive integer, right? So in this case, since 1 is the smallest positive integer ever in the world, unless you're dealing with decimals or something. So in this case, since 1 is not there, 1 will always be the smallest positive integer if it's not included in the array. So we could just return 1 because that's the smallest positive integer that is not included in this array. So now that we understand this question, y'all, let's get into the fun part, the actual solution, y'all. Solution's not that difficult either. Now, what we want to do is we want to make sure that we implement an algorithm that runs on big O of n time and uses big O of 1 auxiliary space. So in order to do that, we're going to use a cyclic sort. Now, excuse me, if you don't know what a cyclic sort is, let me show you and we could go through what a cyclic sort is and how it works before we get into actually writing the code. So a cyclic sort is going to place the number I at its correct index, which would be I minus 1, and it's going to ignore the zeros and or the negative numbers because they'll be irrelevant because we're only dealing with positive numbers, right? And then after we sort, we'll just find the first missing positive number. So let me give you an example of what that's going to look like. So first, say we have an array like this, right? Let's open up this array for y'all. Say we have an array that looks like this, right? And say the integers in the array are 3, 4, or we could just copy this array right here. Boom. say this is the array we have, right? And we want to sort it using a cyclic sort. So what we will do is we'll create another array and we'll sort it. The sort will look like this. So after it's sorted, it will look something like this. And so now let me show you why why it gets sorted like this, because right now you might be looking like these numbers are not sorted. Well, because of the -1. So let me show you why it's sorted like this. So this will be, let's say this is nums, and then this will be what the index up here. Boom. So in a cyclic sort, the index or the nums, each num should be 1 plus the index, right? So this is 0, 1, boom. This should be 1. Then we come over here. That'd be index 1. This would be, come over here. This would be index 2. Come over here. This would be index 3. So as you can see, this right here is 1 plus 0, right? So this is the index plus 1. Boom. Then we come over here. It's the same. But then we come, or it's not the same, but it's not how it's supposed to be, right? But then we come over here, this is the index 2, this is the index plus 1, which is 3. Then we come over here, this is index 3, this is the index plus 1, which would be 4. So this is how it's sorted cyclically, because each element in this, after it's been sorted, will be 1 plus the index. Now we know 2 is missing. This is it's supposed to be like this because this is how we know 2 is the missing positive integer, right? Because this is the only one that it's not following the rules of the index plus 1. Every other integer element follows the rules of the index plus 1. Once again, this is 0. This is 0 plus 1, 1. Then over here, this is 2. The 2 plus 1 is 3. Boom. This is index 3. 3 plus 1 is 4. But we come right here, 1 plus 1, index 1 should be 2. But since this is not 2, then we know 2 is the missing number. And that's how we determine which is the missing number using a cyclic sort. So just remember, it should be, after sorting, it should be like this. Comment it out just so y'all can see a little clearly, but it should be nums square bracket I should equal, or make sure it does not equal, I plus 1. And that's how we determine, this right here is how we determine our missing number, because right here you see this nums I does not equal I plus 1. So we know that this is the missing number. Boom. So now that we know what a cyclic sort is, let's get into the fun part, or a cyclic sort. A cyclic sort. Now let's get into the fun part of actually coding this, right? And the code's not that difficult either. So the first thing we are going to do is we're going to create a helper function to help with this. So we could just say func, call it helper, open up the parentheses, and we could say underscore nums colon. It's going to be colon is going to be an array of integers. Then it's just going to return an integer. Boom, and we can open up the bracket. Now, first thing we need to do is we need to create a mutable copy of the input array. So we're just going to say declare variable called nums, set that equal to nums. Then we declare another variable called I, and we can set that equal to 0. Boom. Now we need to place each number at its correct index, like I showed you in the example before. So in order to do that, we're going to say while I is less than nums.count, we're going to open up the brackets, and we're going to see if the current number is within the valid range and it is not already at the correct position, then we need to swap it to its correct place. So in order to do that, we can say if nums square bracket I is greater than 0, comma, nums square bracket I is less than or equal to nums.count, comma, nums square bracket I exclamation point equal, so does not equal nums square bracket I, does not equal nums square bracket I minus 1, then what we are going to do is we're going to come out here, we're going to open up the brackets, and we are going to say nums dot swap, swap at, open up the parentheses, I, comma, nums, square bracket I, minus 1. So this is kind of just, it's the same thing, it's just backwards. Instead of matching the index, doing the index plus 1 to get the nums of I, we're just going to do the nums of I minus 1 to get the index. Boom. So then after we do that, we're just going to come right here. We're going to say else, open up the brackets, and we're going to say I plus equals 1. So we can increment I like that and move to the next index. Now we need to find the first missing positive number. So in order to do that, we're going to come right here outside of the while loop, and we are going to say for, open up the parentheses, I, comma, num, and nums dot enumerated. So remember, the enumeration is going to get you the element and the index of that element. So this is going to get the index, and this is going to be the num, or the element, and this enumerated nums enumerated is what is going to get us or return us the element and the index, that the corresponding index. Oh, sorry, y'all. Boom. So come right here, put parentheses at the end of that after enumerated. Then we're going to open up the brackets. We're going to say if num exclamation point equals, so if num does not equal I plus 1, then we're going to open up the brackets, and we're just going to return I plus 1, which is going to return the missing positive integer. Then if we go through all of this and everything is sorted correctly, similar to this problem, then we know that the next integer is the smallest integer that we need, right? Similar to this problem where it's 3. We have all 1 and 2 and 0, so we know the next one is 3. So if we go through all of this, we go through all of this, and all of the elements are at the correct index, then we could just come right here and we could just say we could just return the next positive integer by saying return nums dot count plus 1, just like that, y'all. So let's go ahead and give this a, oh, sorry, y'all, that's not gonna run because we didn't call the function. We have to come right here and we have to say return helper, open up the parentheses, and pass in nums. Excuse me. Now let's run it and see if it runs correctly. It should run correctly now. So let's see, and it's accepted, y'all. Go ahead and look at that. So let's go ahead and submit it, see what the time is looking like. Let's see. Look at that, y'all. That's what I'm talking about. 0 milliseconds beats 100% of users with Swift, y'all. Those are some good numbers. Those are the numbers I like to see. That's faster than a brand new Bugatti riding past Andrew Tate and the rest of the brokies down the Autobahn, y'all. That's what I'm talking about. So with that being said, y'all, make sure you get one more look at the code. Y'all. That's the bottom half. That's the top half. And with that being said, y'all, I hope y'all staying disciplined, because your discipline needs to be unmatched with this, especially in this job market. So I hope y'all are staying disciplined, and I hope y'all are continuing down your LeetCode journey. And I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.